class, I'm going to review some of the things about the three-dimensional system that we talked about yesterday. And you can now have like your very own 3D shape since we had all the pods make one. There's enough for everybody. And you can kind of like touch and feel around if you want. Some people are more like hands-on learners than others. Kind of decide what you want. First things first, I want to clarify one thing about the three-dimensional system in mathematics. So previously, we would always hand out regular graph paper, and we would say, like, draw your x and y coordinate axes, and we would graph things on the xy plane, okay? Which is two-dimensional, flat surface, right? Okay. So what we're doing in this three-dimensional system is we're saying, okay, we have the xy plane drawn on our regular graph paper. We're going to turn it flat, okay? So remember yesterday on the 3D system that we created, and if you want to take yours in your hand, orient it so that the yellow XY plane is flat. Okay, that's your two-dimensional system, flat. Okay. And we're going to insert a third dimension, which is going to be Z, and in mathematics, Z is going to run up and down. Okay, so that creates the third dimension, gives us some kind of depth and space to our image. Okay, so you want to orient yours so that the yellow is the floor. Remember, the pink and the blue are going to be the walls. And then kind of like I have in this picture, the yellow triangles are going to be, you know, like that's the XZ plane. So that means that your x-axis is running at the intersection of the yellow and the pink on your model. And so instead of using left, right, up, down for x and y, because we've now made those both flat, I'm going to change the way I describe. X's are going to be forward, backward. Y's, the intersection of the yellow and the blue, are going to be left and right. And then Z's are going to be up and down. So that may be a struggle for some of us just because up and down no longer means Y, it means Z. So X is going to be forward, backward. Y is going to be left and right. Z is going to be up and down. Now, you don't have to necessarily jot anything down. I've seen a few people today who have drawn the 3D system. So if you want to label a 3D system in your notes, you can. But what I am going to do here is just kind of review our octants, and that might be a little bit of information that you might like to write down in your notes about the different octants. So, okay, if you've got it oriented so the pink is coming towards you, that's your x-axis, that line through the pink and the yellow. Okay. Remember, octant 1 is the one that we see the most of when we kind of tilt our three-dimensional space. And in octant 1, if we were at the origin, to get to that point, we would have to move forward, so x would be positive. We would have to move to the right on the y's, so y would be positive, and then we would have to go up, so z is positive. So this is just like quadrant 1 in 2 dimensions. It's your all positive quadrant. So if you want to drop that down to kind of help you, that might be something that you can go back and look at. In octant 1, all the coordinates are positive. Now remember, in the octants, we're going to go like we did for quadrants. We're going to go counterclockwise. So if we're in octant 1, and if you want to touch octant 1 right now with your pen or your finger or something like that, if you're in octant 1 to go counterclockwise, you're going behind octant 1. There's octant 2, okay, behind octant 1. So octant 2 is over here, and you can use regular numbers or Roman numerals. Either one will work. In order to get to that room behind octant 1, instead of going forward on the x-axis, we need to go backward on the x. So that means that x is negative, but we still want to go right and we still want to go up, so y and z are both positives. So these coordinates will all take the form negative, positive, positive. Thinking about octant 3 as we go around counterclockwise, this is the one in the back corner on the first floor. Okay, back corner of the first floor. And to get to that, of course, again, we're moving backwards, so x is negative. This time, instead of y going to the right, we're now moving over to the left side, so y is also negative, but z is positive. So these are going to be negative, negative, positives. And then the last one is the one right next to octant 1 in the front of your three-dimensional image. That's going to be octant 4. You can see a good portion of octant 4 over here. And this one is going to be forward for x, so positive, negative for y to go left, and positive for z. Now, what do you notice about all the z coordinates on the, what I would call the first floor? Z is always positive. So to get all of the octants in the basement of our model, okay, I use the floors and the walls, okay, but to get all the octants that make up the basement, then z has to be negative. But really, your x and y are going to hold true to the room above it, so all you have to do is go around and change those to have negative z's. So octant 5 is right below octant 1, and that's going to be positive, positive, negative. Okay, octant 6, oops, right before. Octant 6 here, okay, underneath octant 2, that's going to be negative, positive, negative. In trouble. Negative, because I got to go down. Octant 7, I really can't see in my image at all, so I'm not even going to label it, but what do you know about all the coordinates in octant 7? They're all negative. We're going back. Gotta get myself oriented. We're going back, we're going left, we're going down. So everything is negative in octant 7. And then over here in octant 8, we're going to be positive, negative, negative. Putting that last one as positive. So that's maybe something for you to think about, that like all the points in those different octants are going to hold true in terms of their signs. Now, I wouldn't necessarily say memorize all 8 of those, but it is something for you to kind of go back and look at and make sense of the pattern that points will land in those octants will have those patterns. Now, of course, there can be points in three-dimensional space that don't live in an octant, because you could have a point that's on one of the planes. Could be on your xy plane, could be on your xz plane, could be on your yz plane. In order for that to happen, one of your coordinates must be equal to 0, because you don't move off the plane. You can also have points that instead of being on a plane, maybe they're on an axis. They're at the intersection of 2 planes. So in order for you to be on the x, y, or z axis, then 2 of your coordinates must be equal to 0. Okay, so you don't move off 2 of the planes. Okay, so that's just kind of something for you to be thinking about as we do our problems. Okay, I'm going to hand you a piece of three-dimensional graph paper. You can use this for the whole chapter. I think we're really only plotting points today, because on Monday we're going to do midpoints and an equation of a sphere, but we don't have to draw the spheres. So you can get all your work on here today. Now you have 2 options on this 3D graph paper. You can make one giant three-dimensional coordinate plane and plot like everything, all your examples and then all your homeworks on the same one, and just label them however you wish. Or you could do like we would used to do with graph paper. You could draw a separate one for like maybe your notes, examples, and then different homework problems. I think you have to graph maybe like 6 different points on today's homework. So however you want to do it. In order to get your coordinate system, to make it look like what it's going to look like for you on your test review and your test, you're going to pick any one of the vertical lines, draw down, that's going to be your z-axis, and then you basically make an x. And I always put my x-axis like this is the positive x-axis over here, like I think about it like it's coming towards me. So that octant 1, I see all of it. And then the y-axis is going over to the right. So you would just draw like your axes on the graph paper. And I'll label my axes here. This is my z-axis. This is my x-axis. This is my y-axis. So I always have it tilted like you see in this picture that I keep putting on every slide, so that like what room do I see all of? I see all of octet 1. Okay, so it's always kind of like rotate a little bit. I mean, honestly, three-dimensional space, we could rotate it any which way, right? We could be looking at it dead on. But in terms of your review and your test, it's going to look kind of like that rotated version. Okay, well, I'm going to plot the first point. I'm going to plot A. Let me see what A is. A is the point -1, 3, 4. So if you want to jot that down somewhere, you can. Okay, or if you want to wait until you label it and then put -1, 3, 4 right next to it, whatever works for you. So they always come in alphabetical order. It's always going to be X, Y, Z, and just follow where you should go on the axes. Remember, X, I'm going to think about the one that is supposed to be coming off the page. So it's either coming forwards or backwards, towards me or away from me. Y is going to be right and left for me, and Z's are going to be ups and downs. Okay, so I like to, in the 3D graph paper, I like to trace my path, because then I kind of like figure the space a little better. So I'm going to start at the origin, and I'm going to go -1 for X, which would mean I would go back 1, right? Because if my X is my forward and backward motion, I want to move not out of the paper, but behind the paper. So I'm going to go back 1. Y is 3, that's positive, so I want to go +3 on the y-axis, which would be to the right. And then Z is +4, so now I need to go up 4. So then I go 1, 2, 3, 4. There's point A. So I kind of trace my steps. I went back, I went right, I went up. In which octet is that point A located? Octet 2. We went behind octet 1, we went to the right, and we went up. So this one here is in octet 2, if you want to label it. Excellent. Okay, I'll do B, and then I'll let you do C and D, and then I'll put them up. Yep.
Is there any way to distinguish like where exactly that point is? Like if you asked where that point was, we couldn't tell you.
Right. So like on your test, I'm going to be asking you to plot points. So I'm just verifying that your point is in the same space as my point, like at the same intersection. But that's kind of like why I draw my pathway. With the path, you can tell I went back, right, and up. But if I don't draw those steps, you don't really know how I got to that. There are multiple ways to get to that location. So the trouble, the trouble with 3 dimensions on a 2-dimensional paper is that, right? That without that perspective of like the path, you don't know where it is actually in space. Of course, Liam, if I were actually plotting that in space, yes, you would know definitively where it is. Okay, 2, 5, 0. I'm going to go forward 2. I am going to go right 5. And because Z is 0, I'm just going to plot a point. Think about on your 3-dimensional system, if you just go forward 2 and right 5, where are you? On the plane. On which plane? The XY plane. You haven't moved off of the floor. You're on the yellow. Okay. So this is on the XY plane. Okay. Makes sense here. If Z is 0, Z is not in the plane that you are on. Right? You are on the XY plane. You have no Z value. Okay, can you plot C and D? And I'll come around, and if you have a big question for me, let me know. I'll try to answer it individually. And then I'll put my answers up so you can check if we're in the same spot. Okay, I'm gonna plot my C, positive 1, right 3, up 6. That one should be an octant. It's in front of the plane that is the YZ plane because we went forward instead of backwards. So it is a little bit of a struggle to see three-dimensionally on a two-dimensional piece of paper, right? Okay, so that's why you gotta imagine like on your three-dimensional shape where you're actually moving. But those are all positive, so that should be octant 1. And then for D, I would go forward 2, I would go left 1, and then up 4. So D is over here. That puts us in octant 4. Excellent. I didn't have any negative Z's here. So, I'll put octant 4 over here. I didn't have any negative Z's, so all of my points are in my upstairs. Any questions, concerns? Okay. Now, I want you to have conversations with your pods. I'm going to give you 2 problems on the next slide, and what I want you to do is, given the information that I provide for you about the coordinates, tell me what octant or octants it could be in. Okay. So I'm not going to give you actual specific points. I'm giving you information like this. So these 3 things go together, narrow down the octant, and then this one is a different problem, narrow down the octant. So go ahead and have a chat with the people at your pods.
So it'd be like the opposite, but the bottom of the opposite.
Oh, yeah. We just went in and out. So like for the second, we would just say so there were options, or do we have to pick a specific one?
You would narrow it down, but there may be more than one.
Yeah, something.
Okay, let's chat and see what we've come up with. Okay, I'm going to have my three-dimensional space out in front of me because I like to kind of like see what I'm doing so that I can start to think about that in my head without the shape right in front of me. I heard some really good conversations right away. You first have to make sense of what the less than and greater than mean, right? So if x is less than 0, that means your x is negative. So instead of going forward towards you, you're going backwards. So now you could choose from quadrant 2 or 3. or quadrant 6 or 7. Okay, so it's one of those four if x is negative. If y is positive, then that means for the y you're going to go right. So now we can't be in these two over here on the left. We're narrowed down to 2 or 6. Okay, and then if z is negative, of course we're in the basement, so we're in octant 6. Okay, so octant 6 is the one that works. Now, if you had memorized the signs that I gave you, or you looked at your notes for negative, positive, negative, you would also know right away octant 6. But ideally, you're probably like thinking that through. I'm going backwards, I'm going right, I'm going down. That's octant 6. Okay, now the next one says yz is less than 0, so that means that yz is negative. How is yz negative? What must be true?
Opposite.
Okay, if they're opposite signs, okay. So we want to name any octant where y has a different sign than z. We're able to come up with any octants that will work for that.
3, 4, 5, 6.
Okay, let's start with 3. Okay, in octant 3, so we're at 1, 2, 3 right here. Think about, okay, of course your x is going back, so your x is negative, but x doesn't really matter here. Your y is going to the left, so y is negative, but then you're going up, so z is positive. So in octant 3, you would have opposite signs, right? Left and up. So octant 3 would work. Think about up on the first floor. Is there another way that you can go left and up? Besides octant 3, you could be in octant 4. That would have the positive x, right? But then, of course, y and z would have different signs. So 3 and 4 will work. That's always a negative y and a positive z, because it's upstairs. And then what octants in the basement will give you opposite signs? In the basement, z will always be negative, so you need to find out which octant in the basement has a positive y. Y is going left and right, so we want to go right. So we would choose octant 5 and 6. Now, if all we know is that they have different signs, that's the most specific that we can get. We wouldn't know anything about the octant until we knew something else about x. Okay? All right, excellent. Last thing that we want to cover today, distance formula. So, just like on the regular xy plane, we could plot 2 points on this piece of paper and find the distance in between them in 2 dimensions. We can now, in our 3-dimensional space, we can have a point over here in octant 1 and a point over here in octant 7, and we can find the distance between the 2 points. It will still hold true from geometry in space that the shortest distance between any 2 points is a straight line. So our distance formula follows very nicely from our 2-dimensional distance formula. We just have to add in the z's, right? It's the difference of the x's squared plus the difference of the y squared plus the difference of the z squared. Let's find the distance between these 2 points. 3, 1, 4 and 0, negative 1, 2. So I'm going to say distance equals the square root of, and then just go through one at a time. Subtract your x's, 3 minus 0 squared, plus subtract your y's, 1 minus negative 1 squared, plus subtract your z's, 4 minus 2 squared. Go ahead and find the differences. So I'm showing all my work here. That would be 3 squared plus, this is going to be 2 squared plus 2 squared In the way that I subtracted them, they all came out to be positives. But remember, if any of the differences are negative, when you square them, you'll still get a positive. So never should you have negative underneath the radical for a distance. And then what is that? 9 plus 4 plus 4? So 17. The square root of 17, and I'm going to say units. Now, follow the same rules as always. Your answer should be in simplest form, so if the radical could be simplified, go ahead and do that. 17 doesn't have any perfect square factors, so we're good. I prefer not to have that in decimal form. Just leave your answer in exact form. We're at the level of math where we really don't need to round for any purposes right away. So just call it square root of 17. Anybody got any questions? Okay. Your homework assignment is in the textbook. And you can get started and you should get finished.